Okay, so now that you're an expert on two-dimensional shapes, we're going to move to three-dimensional shapes. Now, first we're going to do the outside of three-dimensional shapes, and the outside of three-dimensional shapes is called surface area. Don't get it confused with just area. Area is the measure of the inside of two-dimensional shapes, and surface area is the measure of the outside of three-dimensional shapes. Now, the reason they call it surface area is basically what you're going to do is to find the regular area of every side and then add all those areas up, okay? So let me go get my PowerPoint, hopefully, and we'll share that with you, and then we'll kind of start. Now, again, if you're having any trouble, make sure you're contacting me. I don't want you lost. I think you're going to be great. I think this is super easy. So, but I do want to make sure that you're good about it. All right, let's talk about polyhedra. Now, remember, polyhedra is the plural for polyhedron. So the outside of the side of every one on your polygon, on your three-dimensional shape, is going to be a polygon. So the outsides are going to be rectangles and hexagons and squares and triangles and octagons, all those kind of things where there's simple, closed, and straight sides on your two-dimensional shapes. Now, the first one we're going to talk about, this one, what shape is this? I bet you know without me telling you. All right, do you know that it's a square pyramid? Now, I went around the house and look, I found a square pyramid. This is one of my tea boxes, okay? So remember, a pyramid, the sides are mostly triangles, and then it's got one side that doesn't have to be a triangle. So if you've got a side that's not a triangle, that's your base. So this is my base, like this one. You see the bottom is a square. So that's why this one's called a square pyramid. So when it's mostly triangles, it's a pyramid, and then the first name of that shape is any side that's not a triangle. If all the sides were triangles, it'd be called a triangular pyramid. This was a square pyramid. So what we're going to do is we're going to find the area of this square base. We're going to find the area of this rectangle and this one and this one and this one. We're going to add all 5 areas up. Okay, so let's go do it real quick. So on this one, I've got a bottom that's a square. So the first thing I'm going to do is find the area of a square. Remember, a square is a side times another side. Base times height, length times width, whichever one makes most sense to you. So that's why over here I've got 3 5/10 times another 3 5/10. So the area of that square bottom is going to be 12 and 2,500 square inches. Remember, area, always square units. Now look at this triangle on the right side. Triangle area is 1/2 base times your height. Now for you, especially on a test, I would have that right angle drawn. Excuse me, just to make sure that you're right. When you're looking for B's and H's, you're looking for a right angle. So this base is 3 1/2, and that height is 10. So when you say 3 1/2 times 10, you get 35, and then half of that 35 is going to be 17 5/10 square inches. Now don't make an assumption. Like on this one, turn it around and look, but it just so happens because this bottom is a square, this triangle is the same as this one, and that's the same as that one and that one, so I have 4 of them. So what I'm going to do is I'm going to add this square to 4 of these triangles. So rather than saying 7 5/10 added to itself 4 times, it's easier to say 4 times that number. And so that's where I got the 82 and 2,500 square inches. So, you know, if I were marking, I'd go over here and kind of mark. I think that's my right answer on the multiple choice test. Okay, but when you add square inches to square inches, it stays square inches. Just like when you add apples to apples, it stays apples. Okay, so I'm going to clear these drawings. Okay, all right, and then let's kind of go back. All right, and go to my next slide. Now this one is going to be a different kind of prism. Now it looks like this. I went and found a box of cheese straws. You know, when you're self-isolating, you gotta have snacks. Okay, now, so what I'm gonna do is I'm gonna find the area of every one of these rectangles. So I've got 4 around and 1 on the top and 1 on the bottom. So I'm gonna find the area of 6 rectangles and add all those areas up. Now, how do you find the area of a rectangle? Yeah, length times width, very good. Now, this would be a great way to kind of organize it for me on a test. So why don't you kind of get in the habit of doing this on your homework? I've got to find the area of the top and the bottom and the front and the back and the left side and the right side. Now the area of the top, that's a rectangle, so I need length times width. So I know that side's 12, but this side isn't marked, and I panic until I remember, oh, wait a minute. This is a rectangle. So if this side down here is 22, then the side right across from that one right there that I need is also going to be 22. So 12 times 22. So that's why I have 12 times 22, and I got 264. And again, it's going to be square units. Well, on this one, if the top is 264, the bottom's going to be 264 because the top of the box and the bottom of the box are the same rectangle. Now let's look at the front. Okay. So on this front, again, I've got another rectangle. So length 28, but again, I'm missing that width. But like before, if it's 12 on this side, it's got to be 12 straight across from there. So this is 12. So that's why I have a 28 times a 12 over here. Remember, order does not matter when you're multiplying, commutative property of multiplication. So I got 336 square centimeters. And again, if this front rectangle is 336, that back one's going to be another 336. And then I've got the left side and the right side. Now it's a little easier to see the right side on this picture. So if this is 22, you know, what's that? Well, we're not going to panic. If this is 28, remember the side across from it, that side's got to be 28. So I've got a 28 times a 22. So that's where I got 616 square centimeters. And then this other side, this rectangle right across from it on the right, and the left ones have to match. So I just added 264 to 264 to 336 to 336 to 616 to 616. And when I added all of those up, I got 2,432. And then don't forget that you got square units when you're doing area and surface area. Both of those are square units. Let's go do another one that's a little bit more unusual. Now let me kind of erase those notations I had before so it doesn't confuse you. Now this one's a prism, so I know it's a prism, but what kind of prism is it? Well, what shape is on the top that's not a rectangle? Now I would draw this for you in a test. That side is parallel to that side. So when I've got one pair of parallel sides, that's a trapezoid. So this is a trapezoidal prism. So I've got to find the area of the trapezoid on the top and the trapezoid on the bottom, and then all four rectangles going around. So remember your formula for area of a trapezoid. 1/2 the sum of the bases, that B1 plus B2, and then times your height. And remember, the bases are the sides that are parallel. So that's how I know that this one is 15, but I need to know that length. It's not marked, but I'm not going to panic. I'm going to look at my figure. This is a rectangle on the front. So if that's 5, then the side across from it right there's got to be 5. So that's 5. So that's why I've got 5 plus the 15. That's the length of the parallel sides. Then remember, the height's got to be perpendicular. So I drew that right angle so you know that that is perpendicular to that. Okay? So that height is 7. So remember your order of operations, parenthesis first. So 5 plus 15 is going to give me 20. Half of 20 is 10, and then 10 times 7 is 70. So if that top trapezoid is 70 square meters, that bottom's going to also be 70 square meters. Now look at this rectangle on the front. Again, length times width. And that's not marked, but like before, look and see if something's missing. If that side is 6, then the side across from it's going to be 6. So I've got 5 times a 6. So that's where I got the 30. But notice this front rectangle is not remotely the same side as that long back rectangle. So don't make assumptions that opposite sides are always going to be congruent, because they're not. You have to look at the shape. That back rectangle, the length and width are 15 and 6. Now do you see why they're 15 and 6? This back one, it's 15 across, and then the width is 6 right there. So that's where I got the 90. Now look at your left and your right rectangles on the side. Again, this is a rectangle, and just like before, if this is 6, that's 6. And if that is 6, then that one's got to be 6. So I've got 10 meters times 6 meters. So I got 60 square meters for the left side. Then I went and double checked to see if the right side just happened to match. 10 times a 6. Then I added the 70 plus 30 plus 90 plus 60 plus 60, and I got 380. And surface area is always square units. When you add square meters to square meters, you're going to get square meters. Now we're going to talk about a cylinder. Now, I want to show you this slide, and I'm going to kind of talk you through it, okay? But I'm going to kind of shrink it for a second. I'm going to kind of go up here and quit sharing the screen with you for a second because I want to show it to you. If I've got a cylinder, all right, do you see that I've got a circle on the top and a circle on the bottom? So I'm going to have to add the area, pi r squared, and another pi r squared, so I'm going to get 2 of those. But what about this part around, okay? Now, when it made a cylinder out of paper, we kind of talk about, so I need to know how much area this white paper around would be. And I think, well, I know a formula for that. Well, I don't, except I do, okay? I'm going to cut this part, and I'm going to unfold it so you can see. Now, I'm not changing how much white paper is because I unfold it. So the unfolded area is the same thing as the folded area. Doesn't that look like something that's familiar to you? That's a rectangle. Well, you know how to find the area of a rectangle: length times width. Now look what this width was before you folded it. That width was the height. So that h is going to show up. Well, now what was this length right here on the bottom or on the top? Like, look what happens before I cut it. Do you see that that was the distance around my circle? What do you call the distance around a circle? Circumference. So how do you find circumference? Pi times d. So this length right here is pi times d. Now let me warn you about this first slide. They're going to say 2 pi r, but we've already talked about in a previous video why I'm not too keen on 2 pi r. I personally prefer pi d for circumference. But that's from the 2 circles. That's where that formula comes from. And then pi times diameter times height. Okay, so that's where that comes from, that pi dh. Okay, so that's the formula for the surface area of a cylinder. All you need to know is the diameter or the radius, because when you know one, you automatically know the other one. So let's go look at one. Look at this one. There's our formula. All right, 2 pi r squared plus pi dh. Now look, this 8's all the way across. So if the diameter's 8, halfway across is going to be 4. So you see why the radius is 4? And then how tall is this cylinder? Well, it's 12 inches tall. So that 12's the height. Order of operations, I don't have anything inside of parentheses to do, but I do have some exponents. So 4 squared is 16. And then 16 times 2 is 32. So I get 32 pi when I do this one. And then 8 times 9 is 96. So I get 96 pi here. Now, when you add apples to apples, you get apples. So when you add pies to pies, you get pies. So 32 pi plus 96 pi is 128 pi. And then remember, surface area is always square units. Now, you could put this for your answer on a test, exactly 128 pi square inches. Or you could give me a decimal approximation. But if you substitute that 3 14/14 for pi, make sure that you change this down here to approximately equal to. Don't put equals or I'll count off. Because remember that approximately warns somebody that you rounded. On a test, you can give me an exact answer or a decimal approximations. Exact answers have equals, approximations have approximately equal to. Okay, let's look at one more to make sure you're good. I'm sure you are. Same formula, 2 pi r squared plus pi dh. But this time they gave me the radius. But that's okay. If I know the radius is 6, then double that would be the diameter, would be 3. The radius is 3, the diameter is 6. And then how tall is it? Well, it's 9 inches tall. So when I squared the 3, I got 9, and 9 times 2 is the 18. So I've got 18 pi, all right? Plus I've got 54 pi. Now we've talked about this a little bit before, but let's double check. Remember when you factored in Algebra 1? You can't think about it like factoring out a pi. All right, so if I factored a pi out and then pull what was left inside, now I'm not very good at drawing with this little pencil on the screen with my laptop keyboard, but we'll give it a whirl. All right, do you see that if I factored out that pi, that I would have in a parenthesis 18 plus 54, and remember you do parentheses first. So 18 plus 54 is 72, so pi times 72, 72 pi. When you add pies to pies, you get pies. And again, square units on area or surface area. And again, if you decide that you want to substitute 3 14/100 as an approximation for pi, make sure that you give me approximately equal to. If you leave it exact, give me equals. Either one of those two underlined answers will be fine with me on a test. For elementary kids, they really are better off doing a decimal approximation because they want that pi is a little abstract. They don't realize that that really means about triple these. So you want to do it that way if you had that. Now, do you see that I hope it helped you a little bit maybe when I showed you how that formula for cylinder by unfolding it came up? So don't just give the kids formulas to memorize, kind of show them where those formulas come from. So surface area is the outside of two-dimensional shapes, square units. So polyhedra, just add up all the sides and then learn that formula for the cylinder. Now realize on your third test, you're going to have your notes in your book, but on that praxis test, you're not. So you need to kind of go start learning those formulas. Next video, we'll deal with outside surface areas of cones and spheres. If you're having any trouble, then make sure that you come see me. Okay? All right.